Hello everybody and welcome to Area of Regular Polygons Day 1. This is 10.3 in your book if you're following along. Hello geometry. Bam, 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 bam. Okay, check it out. You know how to find areas of all these shapes, of course. But did you realize there's a brand new area formula for every regular polygon? And it's 1/2 apothem times perimeter. And you're like, what's a possum? No, not a possum. An apothem. An apothem. 1/2 times the apothem times the perimeter. Now we didn't know the perimeter is all the way around. Perimeter, the distance around a polygon. This perimeter of the square. Perimeter of a regular 1, 2, 3, 4, 5, 6, 7-agon, septagon. Perimeter of a regular hexagon. Pentagon, octagon, nonagon, decagon. Perimeter is all the distance around. But every single regular, meaning equal shapes and equal sides, polygon has an apothem. Now, the apothem is the distance between the direct center of a shape and one of the sides. It goes from, and I'm going to draw it in here, it goes from the very center of the triangle and drops and makes a perpendicular from the very center of the square, drops and makes a perpendicular. So each of these, we're going to spend a couple different days talking about these. Very, very, very center. Very, very, very center. And it's hard sometimes to see the center of a shape. It's like the balancing point. And you'll see here, like in this pentagon, if you imagine all the heights crossing, all the heights would cross right here. It's also the center of a circle that's outside and inside. And if you drop the perpendicular down, oh my goodness, drop the perpendicular down. Oh my goodness, decagon. So there's all these different oops. So it's gonna be here, it's gonna be like here, it's gonna be like here, and like here. Okay, so more like that. Now, the reason this is important is because if these are all the apothems, these actually create triangles inside of all of these. Now, this triangle right here, I gotta say this first before I begin. Every single regular polygon has a radius. And you're like, this is kind of confusing. I thought radii were just for circles. Well, if you were to hold this triangle down at the center and go and spin it all the way around, a big old circle, circumscribed circle would go around this triangle. And this right here would be the radius of that outside circle. So this is a radius, and this is an apothem, and the perimeter, of course, is all the way around. And on a triangle, it turns into a 30, 60, 90, which is kind of cool. If you were to draw this triangle on a square, you guessed it, here's the apothem, here's the perimeter. This one is a 45, 45, 90. On a septagon, we'll talk about how to find these angles tomorrow, or next lesson. On a hexagon, this one's pretty simple because remember the interior angle sum, well, the interior angle of a regular hexagon is 120. So that means this 120 is split into 60, 60. And so this is also a 30, 60, 90 with the apothem being here and the radius. The apothem, we'll deal with this one later. Again, a pentagon is not a perfect one of these because the angles are a little bit different because it's not a 45, 45, 90 or a 30, 60, 90. But the other one I wanted to show you was this, this octagon. Because in an octagon, this guy, well, let's think about this. In an octagon, this is a 135 inside, 45 here. 135 divided by 2 is 67.5. Okay, so that means this guy is 22.5. Interesting. Okay, so we'll get to that one later, as well as this, sorry, and as well as this skinny little right triangle. So all of these triangles, and we're going to focus mostly on our shapes that we have really nice Really nice angles in, and for now, that is equilateral triangles, squares, and hexagons. Now, if you remember, in every 30, 60, 90, if this side is my shortest, this side is shortest root 3, and this is double it. That's good. But if I were to give you the side for the 60 one, you have to divide it by 3 root 3. Yep. So now when I multiply this by root 3, the root 3 times the root 3 would be 3, and the 3's would cancel out. And this side, of course, is double whatever the shortest side is. We kind of hope that doesn't show up too much because that's a little messy. But we remember in a 45, 45, 90 that if both of these are x, this side is x root 2. And if this is the x I give you, just cut it in half and put a root 2. Just cut it in half and put a root 2. So this is the premise of what we're going for. So I want you to imagine if I were to give you, like, hey, I'd like you to find the area of a regular triangle with apothem 4, we would have to figure out, oh, well, if that's 4, then I need to find out what the perimeter is and just do 1/2 apothem times perimeter. And I'll just talk over this one for a second. Like if this one was 4, you'd be like, oh, well, if that's 4, that means this is 4 root 3. And then now you have 24 root 3 as your perimeter. You have the apothem as 4, and you just do 1/2 apothem times perimeter. The problem is that sometimes, every once in a while, it takes a little bit of time to find either the apothem or the perimeter, and that's okay. So you'll just have to figure out how to work with that and how to use these triangles to do that, and I'll help you through that as well. If you find that you're like, whoa, nuts to that, I'm just going to find the area of one triangle and multiply it by 1, 2, 3, 4, 5, 6. I'm going to find the area of one of these equilateral triangles and split it into 6. That's fine as well. But this is the intro, and now in just a minute, we're going to try to find the areas of triangle, 3 triangles together, 3 squares together, and 3 hexagons together. And then for homework, you guys are going to do these 9 questions here, which are pretty much going to be the same as these, just with different numbers. So click on the next video for how to find the area of these 9 shapes.